Alright guys, last week some of you had trouble with ordering and comparing fractions. So I'm going to just do a little reteach video to help anybody out. So we always want to start with our half strategy. This kind of rules out a lot of things that we don't need to do. So when I think of the half strategy, I look at each one and I'm using a half as a benchmark. So when I look at 5/10, I say, oh, wait, 5 is half of 10, so this is equal to a half. But then when I look at 3/5, I say, oh, well, half of 5 is 2.5, so that means this is going to be bigger than a half. So if this is bigger than a half and this is equal to a half, I know this one's bigger. So a little reminder, the smaller number gets 1 dot, the bigger number gets 2, and I can just connect my dots. Or some of us like to say it's eating, the small number is eating the big number. All right, we can also draw a picture. So I start by representing with my whole, and then I'm going to show it as a fraction. So when I'm doing fifths, I kind of just go down in the middle here and then make an X. Not perfect, but it will get us to the point we need. And when I'm showing tenths, I'm going to do the same thing, but now I have to make smaller pieces in here. So when I shade in my 3/5, and then I'm going to shade in 5/10, I can now see, oops, another way. It's not perfect because fifths, 10ths, it's hard to draw that, so unless we're like really perfect at it, it's not always the best strategy, but sometimes it just helps us visualize it a little bit. All right. So to review, if you look at the numerator and it's half of the denominator, it is equal to a half. So for instance, a lot of times kids do this. And they say to me, that's bigger. If they had used the half strategy, they would have said, oh, half of 6 is 3. So these are equal to each other. That was a mistake I saw last week with a lot of people's answers that were shared with me. All right, so my next, oops, sorry, got projects everywhere. Move that. Ah, a little crash landing. It's gonna fall, that's all right. Okay, 1/5 versus 2/5. So this time we have what we call a common denominator. Because they are the same number of parts, this is kind of like business as usual. It's kind of the easiest ones to do. So that means the smaller the numerator, the smaller the fraction. So those are usually pretty quick and easy, and I think all of you did okay on that. Now, common numerator, a little bit different, because when I have a common numerator, it's the opposite of this. It means the smaller the denominator, the bigger that fraction is. I also could have used the half strategy on this, and that would have helped me out too, because 6/12 is equal to a half, and 6/8 is bigger. But getting back to what we're talking about, so suppose I had, let's do 3/8 versus 3/12. So these are both smaller than a half, so I can't use my half strategy. But because they have a common numerator, the smaller the denominator means it's the bigger fraction. Why is that? Think to myself, okay, well, think about it. If I have a circle divided into 8 equal parts versus a circle, sorry, it's really messy. And we're gonna do this one. This is going like this. What do we notice about our parts? These pieces are much smaller than these pieces. So kind of makes sense that way. All right, last one. These are both smaller than half. I can't use that. Oh, silly me. I'm not gonna do that, okay. So let's do this. 2/3 versus 4/5. There we go. All right, that makes more sense. So now, when we look at these, they're both bigger than a half. 2/3 versus 4/5. They do not have a common numerator. They do not have a common denominator. But we can make a common numerator or denominator. I could turn the 2 into 4 by doing what? Let's think. 2 times what equals 4? 2. Or 3 and 5, if I look at them and I start skip counting by 3s, 3, 6, 9, 12, 15. I say, ooh, 15. 5 can turn into 15 and 3 can turn into 15. But for this one, it seems like it's a little bit easier just to turn the 2 into a 4. So when I'm creating a common, an equivalent fraction, remember, if I multiply the top by 2, I also have to multiply the bottom by 2. So this new fraction would be worth 4/6. So now I'm going to write this out. Which one's bigger? Let's go back to the common numerator rule. When I have a common numerator, the smaller the denominator, the bigger the fraction is. So boom. Okay, I hope this helps. If you have any further questions about it, feel free to post it on Dojo or add to the thread on Google Classroom. All right, peace out, guys.
Peace out, girls.